Alright, so I'm going to start walking through the simulation by starting at the beginning and moving towards the end. So starting at the source, we have the arrival rates of the shipments, which is the rate at which it gets to the docks. And we did this by adding a rate table in the data tab. This data was given by historical data. We imported it here and then applied it at the source over here. So once the shipments leave the source at that arrival rate, the distance here is set to drawn to scale true, so it's not wasting any time. At the transfer node, we used a cyclic cycle to select which dock the trucks will unload at, and we decided to go through from the first one to the last one. Every dock gets one shipment before any dock will get more than one. And we did this to maximize efficiency because it'll minimize the backup at any single dock. So then once it gets to a dock, the shipment here, processing time was inputted here from the data given, and the copy quantity of this separator node, because each dock here we made a separator, the copy quantity is the number of pallets per shipment, so the number of pallets that are in each truck, and that distribution was inputted here. Later on in this presentation we'll show you the distribution. So after it leaves, the parent node of each separator was set to destroy the entities. As you can see, nothing's coming out here. And over here we made a list of workers to carry the pallets from the dock to the aisles, which are all up here. So down by the workers, we have worker shift 1, worker shift 2, and a robot shift 1 and a robot shift 2. These workers never work at the same time, and they're replicating the same set of workers. The work schedule for both are the same actually, and that's right here. Shift 1 and shift 2. Here we have shift 2, shift 1, the hours for shift 1 here, and the hours for shift 2 right here. So if we go back to a worker, let's say worker shift 2 for example, you can see the shift 2 work schedule was implemented, as well as the cost to the company, which is $29 an hour. We'd used usage and idle, because even if he's not working, if he's still on his time, he's getting paid. For the robot, we used a capital cost of $150,000, because that's the price that the company will pay for the robot. Another thing at each separator that we did was aisle assignments. So we used an add-on process here to decide which aisle, again using a distribution that will be shown shortly. And let's get a little running action here. Throw it into 3D. Computer's a little slow, but here we go. So here at the results, we can see go to the sink. These are the docks. What docks are getting what. So while it's running, let's go back to one thing that I forgot to mention earlier, is we had made a transporter list of the workers and the robot pallet jacks. And it's in this order because that's the order that they want to get. Like if a worker is available, you want to get the worker to bring it to the aisle first before you request the robot pallet jack. So over here at the dock, this goes the same for every dock. For secondary resources, we have the same list, and at the single node where they leave, we have ride on transporter, select from list, the list that I showed you earlier, and preferred order, because you want to go in that order, and we reserve closest because that's the one that's going to maximize efficiency. So it's done running now. We'll stop it and go to the results. Let's check out the aisles. So over here at the aisles, it's saying 319. We ran the simulation for 7 days, and 319 went to this aisle, 377 went to this aisle, 204 went to this aisle, 430 went to that aisle, sorry. So my point here is that the amount of shipments that go to each aisle comes pretty close to the historical data that we got. Also here we have the experiments run 400 times. Another thing in the results is if you go to the separators, which are the docks, you can see that the input for the first one was 7 here, but all the other ones are 6. And the point of this was to minimize the backup at each dock, which we think we did effectively. So in the experiments, we added a response variable for the time to aisles, and at each entrance node to the aisles, we have a tally statistic here using the time in system, and that's at each aisle. And you go back to the experiments into the reports, you can see the average time to aisle of each pallet. One thing I want to mention here is that we only ran one experiment for the presentation because my computer does not run over 100, but in the file we're going to submit, it's going to have over 100.
We also included worker utilization as a response variable, and we calculated this kind of in a different way. We took the utilization for each worker, so worker for shift 1, worker for shift 2, the robot for shift 1, and the robot for shift 2, and we add their capacity scheduled utilization together and divide it by 4 to get the average across all workers and robots in the system for their utilization. So to determine our shipment rate that was determined at the source, this is what our rate table was based off of. The numbers you see here come from the historical data. So for the historical data, we divided the shipments into arrival times, and then we put it into a histogram here to determine at what time of day our shipments are arriving. So the data you see here is based off the 3-week period that was given in the historical data, and you can see that most of the shipments happen in the early morning, starting at 5 a.m., picking up at 6 a.m. There's a peak around 10 a.m. And 12 p.m. And then starting at 3 o'clock, there's another peak. And then there's a few more shipments that tend to come in at starting at 8 o'clock, and I think it's 11 o'clock. And then for determining the pallets per shipment, which is where we copy the shipments, so to speak, in the separator, the number of copies are determined by this right here. So it's not necessarily a normal distribution, and it did not fit any other distribution that we tried. So we used an empirical distribution in order to determine the pallets per shipment. So we did buckets of 10, and then determined the distribution for each increasing bucket of 10. And then once we determined the shipments, the number of pallets, we assigned these pallets specific aisles to go to. And looking at the PDF, it isn't necessarily uniform, but it is very close to uniform distribution for the assignment of aisles. And looking at the CDF here, you can see it somewhat follows a uniform distribution, but generally that is what we saw when looking at the data.